So we know that when we have numbers in scientific notation, it's kind of a shortened version of what our actual number is in standard form. So let's talk about how to write numbers that are currently in scientific notation into standard form. So maybe sometimes they're a little bit more easy to understand or more applicable to the situation that we're in. So the absolute value of the exponent indicates how many places we need to move our decimal point. If the exponent is negative, we move it to the left. If it's positive, we move it to the right. And to remind you, scientific notation basically is something times 10 to a power, to an exponent. So that exponent will either be positive or negative. It's going to be an integer. That'll tell us how many places we need to move our decimal and also in which direction. Another thing to remember is that negative exponents mean that your number is really, really small. Positive exponents mean that it's really big. When we talk about negative exponents, we're not talking about a negative value. So we're not saying that these are in the negatives, like a temperature would be really, really low in the negatives. We're talking about a really small fraction of a piece. So a number between 0 and 1, really small number in between 0 and 1. So let's go ahead and let's take a look at some examples. So the first example is here, 7 times 10 to the 7th. So basically what we do is you start with our number, which is 7. We think about where the decimal would be if it's not currently written there. So right now the 7, we don't have a decimal. We know that it would fall right after that 7. So now we need to write it in standard notation. Again, the exponent will tell us how many places to move and in what direction. So our exponent is a positive 7. So we're going to move to the right since positive numbers go to the right. And then we're going to move it 7 places. So we'll take our decimal where it currently is. We'll move it right 1, 2, 3, 4, 5, 6, 7 places. And then we're going to fill in all these empty spaces with zeros. All right, again, we know our decimal would fall right here at the end once we're finished with that. So now we basically have our number written, but we want to clean it up. We want to make it look a little bit nicer. So let's go in and let's place our commas where they should belong. And then we'll rewrite our final number a little bit cleaner without all of those extra little hoops. And we see that 7 times 10 to the 7th in standard notation is actually 70 million. All right, the next one. So in this one, we starting with 8. So again, we're going to start with 8. Decimal would follow that immediately after. We see that our exponent in this case is a negative 3. So negative numbers will move in the left direction. And we know it's going to move left 3 places. So we take our decimal. We move it left 1, 2, 3 places. Make sure that we actually move it there. We're going to fill in these empty spaces with zeros. And again, we're going to clean it up a little bit. So we don't need to worry about commas when we have a decimal, but we do want to make sure that we're writing it how we would typically write a decimal value. So our whole number would be 0, and then we have 0, 0, 8. All right, so there would be your number in standard notation. Let's continue. So 5, here we see the exponent is a positive 2, so we move over 2 places, fill in with place holding zeros. This number in standard notation would be 500. Next example, we already have the decimal there for us, so we don't have to think about where that would be. Our exponent is a negative 4, so we're going to take our decimal, move left 1, 2, 3, 4 places, fill in any place holding zeros, and then rewrite this in a little bit cleaner form. So 0.00027. So as we're about halfway through these examples, there's a couple things that are important. So it's important that we actually move our decimal. So what you don't want to do is you don't want to write this, let's say, as 0002.7. You don't want to write that and leave the decimal where it is, because then you haven't changed the value of what that number actually is. So now you're saying basically it's just 2.7, which is not our original value. So we want to make sure that decimal actually gets moved to a new location. We don't want to leave it where it is. We want to make sure that we are keeping our value equivalent to the original. Also, the other piece is, especially when dealing with the positive exponents, you cannot simply count the number of zeros to determine or you can't use the exponent to determine how many zeros there are going to be. In the case of number 15 here, You can see that the exponent was 7 and there were 7 zeros. You can see here the exponent was 2 and there were 2 zeros, but that will not always be the case. So for instance, in example number 20 here, 2.1 times 10 to the third, if we take our decimal and we move it, in this case, right 3 places, add in our commas in the correct locations, we're going to see that our number here would be 2,100. Notice in this case, the number of zeros does not match the exponent. And we'll see that happen more and more often depending on which numbers we have. So if you just have a whole number with no decimal component, then you will find that the exponent will match the number of zeros. However, if you have any other piece of decimal, it's not going to match up. So you always want to make sure that you are double checking these to make sure that it moves the correct number of places. All right, I'm going to come back and I'm going to do this 4.4 times 10 to the negative fifth. So in this case, we are going to move our decimal 5 places to the left, since it is a negative exponent, which will leave me with 4 zeros after the decimal, so 0.000044. Number 21 here, so we have 1.66 times 10 to the ninth. We'll move our decimal 9 places to the left. Fill in with zeros. And then we'll add in our commas so that we're sure we know exactly what this number is. Makes it a lot easier to actually read the number then as well. (3.85) times 10 to the negative 8. So we're going to go left 8 places and fill in with zeros. Looks like we have 7 zeros there after our decimal. So 0.234567385, going to be that value there. Last one here, 9.725. We're going to move our decimal right 6 places. 1, 2, 3, 4, 5, 6. Fill in zeros in those empty spaces, add in our commas, and there we see our number written in standard form. All right, so again, the decimal will tell you how many places to move your decimal, and the sign of the exponent will tell you which direction. Negative exponents will move in the left direction, so the decimal will move to the left. Positive exponents will move to the right. That ensures that our negative exponents are signifying really small numbers, and our positive exponents are signifying really large numbers.